Hello and welcome to Mr. Tompkins Ed Tech. In this video I'll identify the top 10 most likely topics you'll encounter on a calculated paper and run through some of the typical exam questions to help you prepare for that paper. There is a worksheet that goes with this video and I strongly recommend that you try the questions first yourself before watching. Thanks to Dawn Crichton from Spencer Academies Trust for pulling this worksheet together, by the way. You'll find the link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Okay, so for my first top topic, I've got factors, multiples and primes. So you're going to have to be able to find factors and multiples and primes. Knowing your primes and things like that is quite handy, and you need to be able to find HCF and LCM. Now this is the calculator paper, so I'm going to show you how to do it on a calculator if you didn't already know. Now if you've got the newest calculator, it'll actually find HCFs and LCMs for you without much problem at all. You can just tell it, you can just type your numbers in, it will tell you. The function is a little bit hidden away. So to access the function, you're going to have to press the catalog button, unusually, and then go down to numeric calc. And then you see you've got GCD, that actually stands for greatest common divisor, which is another name for HCF. It's a bit of an Americanism actually, but you know, HCF is what we generally call it, and then LCM is LCM. So if I want to find the HCF of two numbers, I'm going to select the GCD function, and you see it writes down a GCD open bracket. I just then need to type in my two numbers. So in this question, I've got 75 and 105. So type in 75, 105. Should really close the bracket. I don't think you need to, but you know, I'll press it. And then that's going to tell me the answer, and the answer is 15. Okay, so yeah, I can just type in straight away. And then similarly, for question 2, find an LCM. If I go to catalog, numeric function, press the LCM button and press 120, 144, it's going to tell me the LCM straight away. Now I know lots of you won't have that calculator this year, so I'm gonna show you the other way of doing it as well. So if you've got the new one, might as well do it that way, mightn't you? Otherwise, I'll show you how to do it with prime factors. Okay. So alternative method is to use prime factors. So if I can rewrite 75 as a product of its primes. Now again, if you've got the Casio calculator, there's a handy function on here for finding prime factors. So I'm going to just type in 75 equals and then press shift and then the fact key, and you see it writes it as 3 times 5 squared. I'm just going to write that as 3 times 5 times 5, and then the other one, 105, 105 equals and then shift fact. That tells me it's 3 times 5 times 7. Okay, and then the HCF is just every pair of numbers that are in both. Okay, so I've got a 3 in both and a 5 in both. So my HCF is going to be 3 times 5, it's 15. And that's my answer, 15. Okay, LCM, start off the same way. I'm going to write it as a product of its primes first, if you haven't got the new calculator, and just work it out straight away. So 120 equals shift fact. That gives me 2 cubed times 3 times 5. 2 cubed times 3 times 5. And 144 equals shift fact. That gives me 2 to the power 4 times 3 squared. Okay, and then the LCM is every base that appears. you can see we've got a 2 appearing, we've got a 3 appearing, and we've got a 5 appearing. They're my 3 bases. So the LCM is going to have a 2 in it, a 3 in it, and a 5 in it. But we pick the highest power that appears of that base. So if you look at the 2's, I've got a 2 cubed and I've got a 2 to the 4. So I'm going to pick the higher of those two. I'm going to pick the 2 to the 4. For the 3's, I've got a 3 and a 3 squared. So I'm going to pick the 3 squared. So it's 3 squared. And then the 5, I just got a single 5, so it's just 5. Okay, so my LCM is going to be 2 to the 4 times 3 squared times 5. Now I know 2 to the 4 times 3 squared is 144, it's written here. So I'm just going to times that by 5, and it should give me the LCM of 720. Question 3, written as the product of its prime factors, 672 is 2 to the 5 times 3 times 7. First up, write 252, an unrelated number, as the product of its primes. So again, just the same way as we did a moment ago, 252 equals, and then shift fact. That's going to give me 2 squared times 3 squared times 7. Okay, and then work out the highest common factor of those two numbers then. So what do they have in common? Well, I've got a 2 to the 5 and a 2 squared, so what's in common is 2 squared. I've got a 3 and a 3 squared, so what's in common is the 3. And I've got a 7 and a 7, so what's in common is 7. So multiplying those together, 2 squared is 4 times 3 is 12 times 7. 7 12s are 84, so that comes out to be 84. Okay. Question 4, I'm told that x is 2 squared times 3 times 5 and y is 2 times 3 squared times 5 squared. Work out the highest common factor of x and y. So again, I've got a 2 and a 2 squared, so 2 is common. I've got a 3 and a 3 squared, so 3 is common. And I've got a 5 and a 5 squared, so 5 is common. So 2 times 3 times 5, 2 times 3 is 6 times 5 is 30. So that's my HCF. And LCM, now I've got a 2 appearing, I've got a 3 appearing, I've got a 5 appearing. So every base that appears in either will be part of my LCM. 2 times 3 times 5. And what's my highest powers? I've got 2 squared and 2, so 2 is highest. I've got 3 and 3 squared, so 3 squared is highest. I've got a 5 and 5 squared, so 5 squared is highest. So they're all power 2's then, aren't they? So 2 times 2 times 3 times 3 times 5 times 5, that comes out to be 900. Okay, so that's my LCM, 900. Question 5, Q and R are two numbers. As a product of prime factors, Q is 2 cubed times 3 times A cubed, and R is 2 to the 4 times 3 squared times A squared. Now I'm told the HCF of Q and R is 4056. Work out the value of A. Okay. Now if I was just going to pick out the HCF of those two numbers, I would be picking everything that appears in both. So from the two numbers I've been given, I can see that I've got a 2 cubed and a 2 to the power 4, so 2 cubed is common. I've got a 3 and a 3 squared, so 3 is common. And I've got an A cubed and an A squared, so A squared is common. Now if I type 4056 into my calculator and press shift and then fact, that's going to break it down into 2 cubed times 3 times 13 squared. So you can see then that this part here matches up with this part, isn't it? Because this is all the same here, and that's the same as that. So that bit must match with that bit. So if A squared equals 13 squared, then A must be equal to 13 then, mustn't it? Okay, so A is 13. And then part B says work out the lowest common multiple of Q and R. Okay, so then again, I'm just going to pick out every base that appears to the highest power. So I've got a 2 appearing, I've got a 3 appearing, and I've got an A appearing, which I now know is 13. So that's going to be 2 times 3 times 13. And the highest power, I've got a cube and a power 4 for the 2. So that's going to be 2 to the power 4. I've got a 3 and a 3 squared, so I'm going to pick the 3 squared there. And I've got a cubed and an A squared, which is my 13, so I'm going to pick the cube. Okay, so I'm going to get 13 cubed. So it's going to be 2 to the power 4 times 3 squared times 13 cubed. So 2 to the power 4 times 3 squared times 13 cubed, my calculator says that is a rather large 316,368. And that's my final answer then. Okay. My next top topic is probability trees. So for this topic, you're going to have to understand basic probability, how to find them. You're going to have to know how to populate a probability tree that they give you, or maybe derive one for yourself from scratch. You'll need to distinguish between independent and dependent probability. That's normally like with or without replacement. And finally, you're going to then need to be able to go on and find various probabilities from your tree diagram once it's complete. Okay, so they're all the things you need to be able to do. So let's have a look at question 6. Bag A contains 3 red balls and 7 blue balls. Bag B contains 8 red balls and 2 blue balls. A ball is picked at random from each bag. Complete the tree diagram to show the probabilities. Okay, so the first section is bag A. Look, and bag A has got 3 red balls and 7 blue balls. So the probability of picking a red ball from bag A is going to be the 3 red balls over the 10 balls there are all together, isn't it? So it's 3/10 for that one. Okay, and then for blue, it's going to be 7/10. Now these pairs always add up to 1, so just bear that in mind as you go through. Now here we have got what's called independent probability. The second selection is not going to be influenced in any way by the first, because I'm picking a ball from an entirely different bag, bag B. And that's got 8 red balls and 2 blue balls in it. Okay, so the probability of picking a red one from bag B is going to be those 8 red balls over a total of 10 balls that were in the bag, and then 2 out of 10 for blue. Now because it's independent, doesn't matter what happened the first selection, my second selection is going to be the same in both parts, so it's going to be 8/10 and 2/10 as well. Okay, so that's my diagram complete. Now part B says work out the probability of picking a red ball from bag A and a blue ball from bag B. So we've got one specific route that we can take here then. So it's along that route there and then down there like that. That's the ones we need. Okay, so we want to work out the probability of red blue. Okay, and to do that we just multiply everything along that path. So 3/10 times 2/10. 3/10 times 2/10. 3 times 2 is 6, 10 times 10 is 100. So my answer is going to be 6 over 100. Now you never get any credit for cancelling down fractions in probability questions, so I never bother. Okay, I'm just going to leave it as 6/100ths. Question 7, items made at a factory have to pass 2 checks. 90% pass the first check, the items that fail are scrapped, and then 99% of items that pass the first check pass the second check. The items that fail are scrapped. Complete the tree diagram. We've got an asymmetric tree diagram here because if it fails in the first check, you're not going to check again. It's already just gone in the bin. Okay, so if I've got a 0.9% chance of passing, or 90%, I've got a 0.1% chance or a 10% chance of failing at the first check. And then it says 99% of the items that pass the first check pass the second check. So if I've managed to go down that first pass, then this one here is going to have to be 0.99, and making this one the probability of failing 0.01 there. Okay. Part B says an item is chosen at random before the checks. Work out the probability that the item is scrapped. Okay. Now actually there's 2 different routes that can happen here. Either it fails on the first selection, in which case it is then binned, and then alternatively it could pass the first inspection but fail the second one, and then it would be binned. Okay, so we need to work out those 2 probabilities and then add them together, because it's one or the other, and or in probability means add. So what's the probability of fail? Probability of fail is just 0.1, it's the yellow route. And what is the probability of pass and then fail? That's going to be, following the route down, is 0.9 times 0.01, isn't it? 0.9 times 0.01. Okay, so times them through by 100th, that's going to be 0.009 then, isn't it? I'm going to get for that one. Okay, so then what is the probability that it's scrapped? Well, the probability that it's scrapped is the probability that it fails on the first time plus the probability it passes and then fails. And we worked out that that was 0.1 plus 0.009. So overall then that is 0.109. Okay. Question A. A team has 7 boys and 3 girls. Steve chooses 2 of the team at random. Complete the probability tree. Okay, now this is slightly different from the last couple. This is dependent probability. Okay, I'll kind of explain as I go through. So for the first selection, I've got 7 boys out of a total of 7 plus 3, which is 10 altogether then, isn't it? So the probability of picking a boy is going to be 7 out of 10. Okay, which means you've got a 3 in 10 chance of picking a girl. Now for the second selection, I'm picking a team, so I'm not putting that first boy back into the group to select again. If he's in, isn't he? So whoever we picked in the first at the first place isn't going to be in the pick for the second one. So if I picked a boy on the first selection, I've got 1 less boy to pick from on the second selection. I've got 6 boys, and I've got 1 less student to pick because I've already picked 1. So that's 6 out of 9. Okay. If I picked a boy the first time, I've still got 3 girls to pick from, but I've only got 9 students to pick from in total because I already picked a boy. Now going through the other route, if I picked a girl the first time, then I'll still have all 7 boys to pick from out of 9 students, but I'll have only 2 girls to pick from out of 9 students. Okay, so this is dependent probability. You can see the probabilities here are different from the probabilities down here. Okay, meaning you've got dependent probability. These probabilities are dependent on the outcome of the first selection. Okay. Part B says work out the probability that he chooses 1 boy and 1 girl. So there are 2 possible routes of picking 1 boy and 1 girl. That is picking a boy first selection and then picking a girl. Or alternatively, you could pick a girl the first time and then pick a boy. Okay. So what's the probability of boy girl? Now multiplying along that route, I've got 7 over 10 times 3 over 9 there. 7 times 3 is 21. 10 times 9 is 90. And then probability of girl boy, that's going to be 3/10 times 7/9. Now notice the probabilities come out the same anyway, which is pretty much always the case when you've got these things the other way around. So anyway, so the probability then of 1 girl and 1 boy, that's the probability of boy girl plus probability of girl boy, because in probability or generally means add, which is 21 over 90 plus 21 over 90, which is 42 over 90, and that is my final answer, 42 over 90. Question 9, a bag contains 30 discs, 10 are red, 20 are blue. 1 disc is taken at random and replaced by 2 of the other colour. Another disc is then taken at random and replaced by 2 of the other colour. Another disc is then taken at random. Work out the probability that all 3 discs are taken out are red. Okay, so we've got a 3 tier probability tree here, haven't I? I've got like red and blue on the first selection, and then red and blue there, and then red and blue there, and then I've got another selection, red, blue, red, blue, red, blue, red, blue. Okay, right, so to start with, there are 30 discs and there were 10 red ones, so it's going to be 10 out of 30 and 20 out of 30 on the first selection, isn't it? Now, there's quite a lot to fill out here. I'm probably not going to bother doing all of it because I don't need to work out all of it. I just need to work out the probability that all 3 discs taken are red. So I'm going to concentrate on working just this route out really, because I can't really be bothered to do all that extra work. It's not going to get me any more credit. So 10 over 30 chance of getting red. Then what happens? 1 disc is taken out at random and replaced by 2 of the other colour. Okay, so if I take a red one out, then I'm going to have 1 So I'm going to have 1 less red and 2 more blue than I had before. Okay, so I'm going to have 9 red ones out of a total of, if I took one away and added 2, I've got 1 extra, haven't I? So that's 9 over 31 there. And for blue,
I had 20.
I haven't taken any out and I've added 2 extra, so I'm going to get
22 over 31 there.
Okay, and then for the second selection, or sorry, for the third selection, again, presuming I took a red one, I'll have 1 less red and then add in 2 extra blue ones in. So I have 31, I took a red one out, it takes me to 30, add 2 blue, it takes me up to 32. So I'm going to get 8 over 32 for that one. And then the blue obviously is going to be
24 out of 32.
Not that I need that one anyway, because I'm going along the yellow route. Right, so then the probability of red, red, red is going to be, kind of running out of space, let's budge this over a sec. So red, red, red is going to be 10/30ths times 9/31ths times 8 over 32. And what is that then? Well, 10 times 9 times 8, that's 720, over 30 times 31 times 32, 29760. Okay, now again, I'm not going to bother to cancel it down because you don't get any extra credit. It doesn't say right in its lowest terms. Not going to bother. 720 over 29,760. Question 10. A bag X contains 9 blue balls and 18 red balls. Bag Y contains 7 blue balls and 14 red balls. Liz picks a ball at random from bag X. She puts the ball into bag Y. Mike now picks a ball from bag Y. Show that the probability that Liz picks a blue ball equals the probability of Mike picking a blue ball. Okay. Right, so let's just sketch out the probability tree for this particular situation. So first selection, that's when Liz is picking a bag, and she's picking a ball from bag X. Okay, so there are blue and there are red. What's the probability of getting a blue ball? There are 9 blue balls. There are a total of 9 plus 18, that's 27 balls. So 9 in 27 of getting a blue one, and then I guess then that's 18 out of 27 of getting a red one. Okay. Now on the second selection, depends on what happens the first time, doesn't it? Because I'll just write blue, red along there. So if she picks a blue one from bag X, she's going to take that blue bag and she's going to pop it into bag Y, and then Mike's going to select. So there were 7 blue balls and 14 red balls in there to start with, and if I plop the blue extra ball in, then I've got 8 blue balls and 14 red balls. So that's going to be 8 blue out of a total of 8 plus 14, which is 22. So she's got 8 in 22 chance of getting a blue ball. And then the red, well, there were 14 in there to start with. There's still 14, so it's 14 out of 22. Okay. Now let's assume she picked a red one first time. Then she's going to plonk the red ball in bag Y, in which case there were 7 blue balls in there. There's still 7, so it's going to be 7 over 22. There were 14. If she plops a red one in there, there's now 15, so it's going to be 15 over 22 for red. Okay. So show that the probability that Liz picks a blue ball is equal to the probability of Mike picking a blue ball. So probability Liz picks blue, that's just the probability of blue on the first selection, isn't it? It's just probability of blue, which is this root here. Okay, and then that is 9 over 27. Okay, now the probability that Mike picks blue, he could pick blue after Liz has picked blue, or he could pick blue after Liz picks red. Okay, he could do either of those 2 routes. Okay, so the probability of blue, that's 9 over 27 times 8 over 22. What's that? 9 over, so 9/27. I am going to cancel this one down because I need to compare it with other things at the moment, so I'm going to do it properly. 8/22, that comes out to be 4/33. Okay, and then the probability of red blue, that's going to be 18/27 times 7/22. What's that then? 18/27 times 7/22. That's 7/33. And so the probability that Mike picks blue, that's going to be the probability of blue plus the probability of red blue, those two roots that I just found. Okay, so that's going to be 4/33 plus 7/33, which is equal to 11/33, which is equal to 1/3, isn't it? It's a third. But then again, so is 9/27. That's also a third. Okay, so I've shown that the probability that Liz picks blue is 1/3, and the probability that Mike picks blue is 1/3, which is spookily the same. I can say they're equal. There we go. Job done. Next up is cumulative frequency. Now, I covered cumulative frequency in my top 10 topics for paper 2. If it came up in paper 2, it's unlikely to come up again in paper 3, so you can probably skip this section. If it didn't come up in paper 2, then probably it's going to come up this time around, so you better not skip this one. Okay, so let's crack on and work out question 11. Here is some information about the marks of 60 students in the test. So for cumulative frequency, we need the upper class value for each, the upper M, and we need to have the cumulative frequency here. Okay, so upper M is the upper bound of each of these. So upper M is going to be 50, 60, 70, 80, and 90. Okay, and the cumulative frequency, the first cumulative frequency is just 9, so 9. Second cumulative frequency is 9 and 16. 9 plus 16 is 25. Next cumulative frequency is all of them, so it's down to there. Look, I can add 9 and 16 and then 20, but I already added 9 and 16, it's 25, so it's my last cumulative frequency to add 20, which is 45. And then my next one is going to be 45 plus 8, so that's 53, and the next one after that is going to be 53 plus 7, which is 60. You can always worth double checking at the end that your value here matches the number of things they tell you up here. That's a good check, isn't it? So yeah, all matches up, all good. So it's time to start plotting these values then. Now my first point to plot is 50 against 9, but I can actually plot a bonus point at the lower class bound of my first group there. So I am going to plot an extra point at 40, 0 here, because there was nothing less than 40, because it's the lower bound of the lowest group. And then after that I can plot 50 at 9, which is there, look, and then 60 at 25, and then 70 at 45, 80 goes with 53, and 90 goes with 60. Okay, once you plotted all your points, then you're going to just carefully draw that distinctive S-shaped cumulative frequency curve through each of your points. It kind of flattens out at the top. Okay, so there we go, like that. Right, so there's my cumulative frequency curve. I bet they're going to ask me something about it now, aren't they? Use your graph to estimate the lowest mark of the top 20 students. Okay, so who are the top 20 students? We've got 60 students. 20% of 60 students, 20% of 60, that's going to be 0.2 times 60, isn't it? What's that? 12, isn't it? Just not do it on your calculator if you need to. Remember, it's the top 12. It's the top 20% though, so I don't want the bottom 12. I want the top 12. So if I start at 60 and I come down 12, that's going to take me down to 48, isn't it? So 48 to 60 is the top 12 students, which is the top 20%. So if I then read across from 48 until I hit my graph and down, that should tell me then what mark the bottom person in that group got. Okay, so just reading across to my graph, switch directions, read down. Now I'm making that for my graph to be 72. Now you're going to get a bit of wiggle room on this. If your graph looks slightly different, you have to draw a smooth line, didn't you? It's quite possible we both did something slightly different. Then just read your one off. That's fine. There is like a variation to this question, and the examiners will look at what you did and what your value is from your graph. Okay, so if yours is saying 71, use 71. If yours is saying 73, use 73. Mine's saying 72, so I'm going to say 72. Question 12. The cumulative frequency graph shows information about the masses of 50 apples. Use your graph to estimate the median mass of the apples. Well, the median mark is going to be halfway through. I've got 50 values here, so half of 50 is 25. So I'm going to look across from 25 and then until I get to my graph, and then I'm going to look down. Okay, so my median is going to be here at 25. So the same as last time, read across until I hit the graph, then change directions, and then read down. You can see that's one little square past 105, isn't it? Yeah, so I'm going to read that. So one little square past 105. Got 105, 110, 5 divisions. Each division is 1. I think that is going to be 106 then, isn't it? 106. Estimate the proportion of apples that have a mass greater than 115 grams. Okay, so this one I'm looking back the other way. So I'm going to start at 115 and I'm going to read up to the cumulative frequency curve and across, and then that's going to tell me how many people had that amount or less or fewer, or how many apples in this case had that mass or fewer. Okay, so that's what, 2 divisions above 40 on mine. So that's 42 I'm reading off there. So estimate the portion of a mass greater than 115. Now that 42 is telling me that 42 apples have a mass of 115 or less. So again, what we want to do here is work out that bit there then. If 42 have got 115 or less, then 50 minus 42, or 8 apples, have 115 or more. So it's going to be 50 minus 42, 8 apples are going to have a mass of 115 or greater. Okay, so my next top topic is histograms. Again, I had this on my selection for paper 2 top topics. So you have to think, did it come up in paper 2? Did you already get tested on histograms? If you have, it's unlikely to come up again, and you can probably safely skip this section this time. If you haven't seen it already, then definitely get your head down and look into histograms, because if you've not seen it already, you're very likely to see it in this paper. Right, so let's crack on. Histograms. Question 13. The table shows information about the masses of 400 hamsters, and we need to draw this on the histogram. Now, histograms are not bar graphs. We don't have frequency on the y-axis. We have frequency density. So in order to draw this, we need to know class width and we need to know frequency density. So probably what I'm going to do is, if you've been given a table like this, if you just kind of add a couple of columns on the end of it, it's the easiest thing to do. So, and then I can use those to work out my various values. Okay, so this one is going to be class width, and this one is going to be frequency density. Okay, so the class width is the difference between the lowest and highest amount in that group. So 100 minus 80 in this case is going to give me a class width of 20. 115 minus 100 is 15. 125 minus 115 is 10. And 150 minus 125 is 25. So you'll notice that each one of these bars is a different width. Classic histogram. And then frequency density is frequency divided by class width. So 100 divided by 20, that's 5. 115 divided by 15, that's 10. 90 divided by 10 is 9. And 60 divided by 25, what's that? That's once, twice, and 10 25ths, which is 40 hundredths. So it's 2.4, isn't it? Right, so I'm going to draw those bars then carefully on the graph. So first bar goes from 80 to 100, and it's going to have a height of 5. Next bar is going from 100 to 115, and there's a height of 10. Then we've got 115 to 125 with a height of 9. And then finally from 125 to 150 with a height of 2.4, sorry, which is 2 little squares above 2, isn't it? Okay, so I'm happy with my histogram. It's looking good. Question 14, a train company records the number of minutes T. Some trains were late in 1 month. The histogram summarizes the results. Okay, so we've got frequency density up the side and number of minutes along the bottom. How many trains were more than 15 minutes late? Okay, so more than 15 minutes is going to be all of the bars to the right of 15, isn't it? So it's going to be this bar, and this bar. We need to know the frequencies of those 3 bars. Now remember, frequency in a histogram is class width times frequency density. It's the opposite of how we found frequency density earlier. We found frequency density by dividing frequency by class width. So to get frequency back again, we need to multiply frequency density by class width. In other words, we want to just find the area of this rectangle, don't we? Frequency density is the height, and class width is the length. So if I multiply those two together, I'll get the area of the bar, won't I? Okay, so for the first one, it's 15 to 20, which has a width of 10, times a height of, what's that, 4? 10 times 4, which is 40. The next bar has got a width of 5 and a height of, well, that's 1 little square down from 3, isn't it? So there's 5 divisions between 2 and 3, so each one of those must be 0.2. So I'm reading that as 2.8. So 5 lots of 2.8. What's that, 14? And then finally, I've got one stretching from 30 to 60. That's a width of 30. And a height this time of 1. So 30 times 1, that's just 30. Okay, so adding those up then, 40, 30 and 14, that adds up to 84, doesn't it? Okay, so then that's 84 trains who were more than 15 minutes late. Part B says, which is the modal class? The modal class is always the group with the highest frequency. So we've worked out 3 of the frequencies already. We got that one was 40, that was 14, and that was 30. So far it's that bar there, isn't it, that's the biggest, the 15 to 25. Might just want to check the tallest bar in the first one first, though. That's got a width of 5 and a height of 6, so this is going to be 5 times 6, which is 30. So that's less, isn't it? And the other 2 bars are less tall, so it's not going to be those. So it's going to be that 15 to 25 bar as the modal group, because it's got the most in it. It's got 40 in it. Question 15. The histogram shows the ages in years of members of a chess club. There are 22 members with ages in the range of 40 to 65. Work out the number of members with ages in the range of 25 to 40. So there are 22 members in the range from 40 to 65. That's that last bar on the end here, isn't it? That's 40 to 65. So there must be 22 people in here. Okay. So if that's the case, then what is that value there then on the frequency density? So frequency density is frequency divided by class width. So frequency density is frequency over class width, which in this case is 22 over class width of 40 to 65. That spans 25 units. Okay, so 22 over 25 as a decimal is 0.88. That's not very good. It can't be 0.88. So if you have a look at this scale here, there are 11 little divisions here. So one of those, and you can see it, so if we've got 11 divisions to represent 22 25ths, then each division is going to be 2 25ths then, isn't it? So one little square is going to be 2 25ths. So when I've gone up 11, it's going to be 22 25ths. Okay, a bit of a weird scale, but we only need to use it once. So the 25 to 40 category, that is, it's got a width of 25 to 40. It's got a width of 15, isn't it? So frequency is going to be the 15 width there. And what's the height? So you can see on the scale, it's like 5, 10, 15, 20, 25, 30 little squares tall. So if I times it by 30 little squares, and if each square is 2 25ths, then that should tell me the frequency altogether then, shouldn't it? So 15 times 30 times 2 25ths. So 15 times 30 times 2 over 25, I make that 36. So there are going to be 36 people in that 25 to 40 category there. Okay, 36 in there. Next section is product rule for counting, or another word for this is selection. Okay, so it's the number of ways of selecting certain things from certain things. So question 16, a menu has a choice of 2 starters, 7 main courses and 4 desserts. Work out how many different choices of the 3-course meal are possible. Okay, well, if you've got 2 starters, you've got 2 possible selections you can make there, and then 7 mains and 4 desserts. You just have to multiply those 3 numbers together, because for every selection of starter that you make, you've got 7 choices for the main and so on. So you just need to multiply them up. So 2 times 7 times 4, that comes out to be 56. Okay. These are much more fun when you've got some sort of restrictions on choice. So this second one, Sophia makes a 5-digit number using all of these cards. How many different even numbers can she make? Okay. So you've got 5 slots to fill. Now, if there were no restrictions, you'd have 5 choices for the first, 4 for the second, because you'd already picked one for the first one, then 3, then 2, and the last one kind of picks itself because there's only one left over. So if there was no restrictions, there would be 5 times 4 times 3 times 2 times 1 choices here, but it has to be an even number, which means your choice for the last digit is restricted. It has to be an even number on the end, isn't it? An even number is even because the number on the end is an even number. So you've only actually got 1, 2 choices for that last selection. So when you've got a restriction like that, start with the restriction. So I'm going to put the 2 choices I've got to make it an even number at the end. Either I pick a 4 or a 6. Now, regardless if I pick 4 or I pick 6, I'm going to have 4 selections for my next one. Let's say I pick 4. Oops. Let's say I pick the 4, then I've got 3, 6, 7, 9, 4 selections for the next one. If I didn't pick the 4, I picked the 6, I'd have 4 different selections for the other one. Okay, so then picking another one, that leaves me with 3 selections. Picking another one is giving me 2 selections, and then the last digit kind of picks itself because it's the one left over. So this one is going to be 1 times 2 times 3 times 4 times 2. Okay, so 2 times 3 times 4 times 2, that comes out to be 48. Okay, so there are 48 possible selections for those. Question 18. Here are 2 methods to make a 4-digit code. Codes can have repeated digits. So method A, for the first 2 digits, use an odd number between 30 and 100, and for the last 2 digits, use a multiple of 11. And for method B, use 4 digits in the order even, odd, even, odd. Do not use the digit 0. which method gives the greater number of possible codes? You must show you're working. All right, so basically we need to work out method A selections and method B selections. So let's start with A. Right, so we've got, for the first two digits, use an odd number between 30 and 100. So for the first two digits, I am picking an odd number between 30 to 100. Now, how many odd numbers are there between 30 and 100? Well, I've got the first odd number is 31, then I've got 33, and then I've got 35, and then 37 and 39. So I've got 5, haven't I, between 30 and 39. So I'm going to have another 5 between 40 and 49, another 5 between 50 and 59, and so on. So if I take that by that 5 in each block of 10, and then I've got the 30s, the 40s, the 50s, the 60s, the 70s, the 80s, the 90s, so that's 7 spans of 10 of those. So if I times that by 7, that means I'm going to have 5 times 7. I'm going to have 35 different possible odd pairs between 30 and 100 then, aren't I? Okay, so I've got 35 choices for those first two numbers, and for the last two digits I've got a multiple of 11. Okay, so how many multiples of 11 are there? Well, there's 11, 22, 33, 44, 55, 66, 77, 88, and 99. Okay, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 choices for that one. Okay, so multiplying those together, 35 times 9, that gives me 315 different codes. Okay, right, so what about method B? So method B, use 4 digits in the order even, odd, even, odd. Do not use the digit 0. Now I can have repeated digits, so how many even numbers are there between 1 and 9? So numbers between 1 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't use 0. So the odd numbers, 1, 2, 3, 4 of those, 5 of those, and even numbers, 1, and even numbers, 1, 2, 3, 4 of those. So I got 4 even and 5 odds. So 5 times odd, 4 times even. Okay, so then if I'm picking a code which is even, odd, then I'm going to have 4 choices for the first digit if it's going to be even, 5 choices for the second, 4 choices for the third because I can repeat them in this case, and 5 for the last one because I can repeat it. Okay, so then multiplying those together, 4 times 5 is 20, 4 times 5 is 20, 20 times 20 is 400. Okay, so then there are 400 codes for method B, so 400 codes beats 315, doesn't it? So method B is the answer here. Method B has the most codes. Question 19, Liam is trying to remember a 3-digit code. He knows that the first digit is a cube number, the second digit is a factor of 16, and the third digit is an odd number. Liam tries at random a code that matches the rule. Work out the probability that it's the correct code. Okay, so what is probability? It's successful outcomes divided by total outcomes. So in order to work out that probability, I need to know the total number of codes possible, and then I can work out the probability then, can't I? So let's think how many different choices I got for each of these digits then. So the first digit is a cube number. Okay, well, it's a digit. There aren't that many cube numbers that are 1 digit in size. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Now 3 times 3 times 3 is already too big. So there are 2 selections or 2 choices for that first digit then, isn't there? Okay, 2 choices for that one. The second digit is a factor of 16. What are the factors of 16? Got 1 and 16, 2 and 8, 3 and 4, and that's it. So that's 5 different factors, but only 3 of those are 1 digit, aren't they? That one, and that one. So there are 3 factors. I could pick 1, I could pick 2, I could pick 4. So there are 3 choices for the second digit. And then finally, the third digit is an odd number. Okay, so again, we did this earlier, didn't we? 1, 3, 5, 7, 9. There are 5 choices for his final digit. Okay, so then how many choices there are altogether? Number of codes. It's going to be 2 times 3 times 5 then, isn't it? 6 times 5, there are 30 different codes you could pick. So the probability of a correct code picked at random, he's picking one code, there's 30 different codes that are possible, so that's 1 in 30 then, isn't it? So he's got 1 chance in 30 of getting it right. Okay, next up we're looking at similar shapes. So with similar shapes you'll need to be able to find ratios, or like the scale factor between 2 similar shapes. You need to go and find a matching pair to find that. Use that to find other missing values perhaps. You need to know about the relationship between lengths, areas and volumes of similar shapes. Yeah, and yeah, you need to show how to show that 2 shapes are similar. So if they're going to be similar, then sides are going to be in the same ratio. So if you take these sides and divide them, you should get the same value as if you divide these sides as well. So they need to be in the same ratio. So what's 5 over 12? 5 over 12 is, well, it's just 5/12, isn't it? And what is 8 over 19.2? Type that into my calculator. 19.2. That's also 5/12. Okay, so that's it. So I'm just going to say that both shapes have sides in the same ratio of 5 over 12. Okay, I think that would do. Question 21, the diagram shows a triangle cut into a smaller triangle and a trapezium. Work out the area of the trapezium. Well, the trapezium is here, look. And now to work out the area of a trapezium, we need to know its 2 parallel sides that we've got. We've got 12 and 8. What we need, though, is that length there as well, don't we, to work out the area of a trapezium. And at the moment, we don't know it. Okay? But we've got this pair of numbers that go together. That should tell me the scale factor of the smaller triangle, which is here, and its larger buddy, which is here. Look. Okay, so those 2 are similar because they share the same angles, don't they? They both got right angles at the bottom. They both share this angle in the corner here, and then these 2 are the same as well. Have to be, because the other 2 are the same. Okay, so they are 2 similar triangles. So we can say then that CBD is similar to CAE. Okay, those 2 are similar. So, and then if we have a look at the relationship between AE and BD. So if I take AE and divide it by BD, that's going to be 12 over 8, which is 1.5, isn't it? Okay, so the scale factor between the smaller triangle and the bigger one is 1.5. Okay, so if I look at the length DC, compare it to the length EC, so then EC, the longer one of the 2, is going to be 1.5 times DC, the smaller one that it matches with. Okay, so that's going to be 1.5 times 11. So what's 11 and half of 11? That's 16.5 then, isn't it? Okay, so it's 16.5 from there down to there. If that's 16.5, then this part up here, look, is going to be 11 taken away from 16.5. So 16.5 subtract 11, that's 5.5. So that's going to be 5.5 there, and that's the height then of our trapezium. So then, now I know that, then the area is going to be half A plus BH. That's the formula for a trapezium, isn't it? So that's half lots of my 2 parallel sides, 8 plus 12, times the distance between them, which is 5.5. Okay, so 8 plus 12 is 20, divided by 2 is 10, and 10 times 5.5, that's 55. So that's going to be the area of the trapezium then, isn't it? 55 square centimeters. Question 22, A and B are two similar solids. The volume of A is 500 cubic centimeters. Work out the volume of B. Okay. Well, we've got A to B. Now the ratio of their sides is 10 to 12, isn't it? Okay, which is the same thing as 5 to 6. And that counts down to 5 to 6. So their sides are in the ratio of 5 to 6. So that means their volumes are going to be in the ratio of 5 cubed to 6 cubed. Okay. So if sides are in one ratio, then their areas are going to be in the ratio of their sides squared, and their volumes are going to be in the ratio of their sides cubed. Okay. So volumes of their volumes are going to be a ratio of 5 cubed to 5 to 6 cubed. 5 cubed I know is 125. 6 cubed I think is 216. I might just double check that one. 6 to the power of 3, yeah, it's 216. So I know the actual volume of A is 500. Now 500 isn't that just 4 lots of 125? I think it is. So if I times it up by 4, look, I get 500. So doing the same on this side, what's that going to be? 216 times 4. 216 times 4. That comes out to be 864 then, doesn't it? And then so that is going to be the volume of the big pawn. Okay, is it a pawn? Looks like a pawn. Right, so that is 864 centimeters cubed. Question 23, the diagram shows two pieces of glass. The pieces are similar. The area of the small piece is 6,000 square centimeters. Glass cost £80 per square meter. Work out the cost of the larger piece. Okay, so this is a very similar question to the last one. We've been given the two matching sides, so we can work out the ratio of their sides, and then we can use that to find the ratio of their area. Okay, so let's just put the information from the diagram on from the question onto the diagram first. So I've got 6,000 there. That's that one. We want to work out this one, don't we? Okay, so we've got 50 and we've got 75. So then the ratio of their sides, it's a smaller to bigger one. The ratio of their sides is 50 to 75, and that cancels down. If I write 50 over 75 as a fraction on my calculator, I'll just cancel it down to 2/3. And I'm just going to use those same numbers in my ratio. So that's 2/3. So that's the ratio of their sides. Now we want the ratio of their areas. So just like earlier when we used the ratio of the sides and cubed it to find the ratio of their volumes, if I want to find the ratio of their areas, I take the ratio of their sides and I square it. So it's going to be 2 squared times 3 squared, which is 4 to 9. Okay, so then the volume, sorry, the area of the big one is going to be 6,000, the area of the smaller one, and then divide by 4 and times by 9 then, isn't it? Okay, so divide by the smaller ratio and times by the bigger ratio is going to give me the new one. So 6,000 times 9/4 then. So 6,000 times 9 divided by 4, that comes out to be 13,500. Okay, so then that's the area of the big one. Oh, we need to work out the cost though, don't we? So that's 13,000, so the area is 13,500 centimeters squared, but we want it in square meters. So how many square centimeters in a square meter? Well, if you think about a square meter, 1 meter by 1 meter, it's going to be 100 centimeters by 100 centimeters, isn't there? So 100 times 100 is 10,000 square centimeters in a square meter. So if I want to turn 13,500 square centimeters into square meters, I need to divide it by 10,000, and that's going to give me 1.35 square meters then. Okay, so then the cost is going to be 1.35 times the £80 per square meter. So 1.35 times 80, and that comes out to be £108. Okay. Question 24. These two solid shapes are similar. The volume of A is 1400 cubic centimeters. Work out the volume of B. Okay, now notice again, we've got matching sides given. So A to B, the ratio of their sides is 12 to 15, which cancels down, doesn't it? They're both divisible by 3, so that's 4 to 5. And so the ratio of their volumes is going to be 4 cubed to 5 cubed. 4 cubed is 64, 5 cubed is 125, isn't it? Okay, so then the volume of the bigger one is going to be the volume of the smaller one. So the volume of B is going to be the volume of the smaller one, 1400, and then we need to divide it by 64 and times it by 125 then. So it's going to be that, isn't it? So 1400 times by 125 and divided by 64. I was hoping it would come out to a nice number. It's not quite a nice number. What's that then? Done it right? I think so. I'll make that 2734 and change. Just going to round it off. Okay, hoping that's right. Question 25. Solids X and Y are similar. X's volume 64 cubic centimeters, Y's volume 343 cubic centimeters. The surface area of X is 176 centimeters squared. Work out the surface area of Y. Okay. Right, so we're going to have to work backwards this time. So now we've got X to Y, and we've got the ratio of their volumes now. So X is 64 to 343. Now you'll notice they are cube numbers, aren't they? So 64 is 4 cubed. Luckily I just did those, so I was thinking 64. I just worked that one out a second ago. That's 4 cubed. And then the cube root of 343, what's that then? Cube root 343, that's 7. So I've got 4 cubed to 7 cubed. Okay, that means the ratio of their lengths is going to be 4 to 7, and the ratio of their areas, including surface areas, is going to be 4 squared to 7 squared, which is 16 to 49. Okay, so I know the ratio of their areas is 16 to 49, and I know the surface area of X is 176. So how many times bigger is 176 compared to 16? I think that's 11, isn't it? Because 16 is 160, and I've got another 16 on top. So that's 11 times bigger. So if I times this one up by 11, so 10 49s would be 490, and another 49 would be 539, I believe. Okay, so then that is going to be my surface area for Y then, 539. So that's my answer, 539. Next up, we've got error bounds. So question 26, A is 65 to the nearest integer and B is 30 to one significant figure. Work out the upper bound of 2a squared minus b squared. Okay, so we need the bounds for A and B first. So let's have a think about A. Now, if I had a number line and I marked on 65, now that's the number to the nearest integer. So if I had a scale going up in integers, the next one up on my scale would be 66. The one before it would be one less, it would be 64. Now the numbers that then round to 65 are going to be all the numbers that are like halfway between or nearer. Okay, so what is halfway between 64 and 65? That's going to be 64.5 there, and that's going to be 65.5 there. So my bounds for A are 64.5 to 65.5. Okay, now looking at B, again, that's 30 to one significant figure. That means it's been rounded off after the first digit. So it's to the nearest 10, basically. So if I mark 30 on the scale, now going up in tens, the next digit on the scale would be 40, and going down in tens, the one before it would be 20. Now, what numbers would round to 30? That would be halfway between or nearer. So halfway between 20 and 30 is 25. and halfway between 30 and 40 is going to be 35. Okay, so the upper and lower bounds for B are 35 and 25. Okay, now we want to work out the upper bound of this expression 2a squared minus b squared. Now, if I want to make this as big as possible, then this positive part here needs to be as big as possible. So I'm going to use the upper bound of a. So when I square it and double it, it's going to be as big as it can possibly be. Okay? But then I want to take b squared away. Now, obviously, if I want it to be as big as possible, I want to take away as little as possible. So for b, I'm going to be using the lower bound here. So what I take away is the least possible amount in the range of possible values of b. Okay? So upper bound of 2a squared minus b squared is going to be big A, 2 lots of 65.5 all squared, minus little b, 25 squared. Okay, so that's what I'm going to get. So I need to work that out then. 2 times 65.5 squared minus 25 squared. Apparently that is 7955.5. Okay, right, question 27. A is 4.72 to 3 significant figures, B is 158 to 3 significant figures. Work out the upper bound of A over B. I'll show you working. So a very similar question. I'm going to start off by working out the bounds for A and then of B. So I've been given A as 4.72 to 3 significant figures. The third significant figure is that 2 there. It's in the hundredths column. So if I'm writing a scale that's going up in hundredths, the next number on the scale would be 1/100th more than 4.72, which is 4.73. And the previous one would be 4.71. So the numbers rounding to 4.72 are going to be halfway between those or nearer. So that's going to be 4.715, and that is going to be 4.725. Now I show this method to students, and some of them, they don't like writing stuff for some reason. I think these little diagrams make it very clear, and I recommend that you do it. It's quite fiddly, this sort of stuff. It's easy to make a mistake under exam conditions. I just think like sketching it out like this makes it nice and clear. So for B, 158 to 3 significant figures, the third significant figure again is that units column there. So 1 unit more than 158 is 159. 1 unit less than 158 is 157. So then the numbers rounding to 158 are going to be halfway between or nearer. Halfway between 157 and 158, 157.5. Halfway between 158 and 159, that's going to be 158.5. Okay, so I've got my upper and lower bounds for both A and B. Now I need to work out what is the upper bound of A over B. Okay, now I've got a fraction. To make the fraction as big as possible, I need the biggest possible numerator and the smallest possible denominator. You know, remember, like a half is bigger than a third, so the smaller the denominator, the bigger the fraction. So if I want the upper bound of A over B, I need big A, little b. Okay, so I'm going to use 4.725 divided by 157.5. What's that then? 4.725 divided by 157.5. Apparently that's 3/100ths, or 0.03. Question 28. Edith's van can safely carry a maximum load of 920 kilograms. She wants to use her van to carry 30 sacks of potatoes, each of mass 25 kilograms, to the nearest kilogram, and 30 sacks of carrots, each of mass 7.5 kilograms, to 1 decimal place. Can she definitely use her van safely in one journey? You must show your working. Okay, so what we need to do is consider the bounds of these numbers and then work out which bound we need, and then work out our kind of upper bound, I guess, for the weight. Okay, so let's just do that. So for the potatoes, potatoes are 25 kilograms to the nearest kilogram. So 25 to the nearest kilogram. Next one on the scale would be 26, one below would be 24. The ones that are around 25 are going to be halfway between or nearer, which is 24.5 to 25.5. So that's the bounds for the potatoes. And for carrots, 7.5 kilograms to 1 decimal place. So 1 decimal place is more than 7.5, that's 7.6, and 1 decimal place less than 7.5, 7.4. So what rounds to 7.5? Halfway between those or closer. So it's going to be 7.45 up to 7.55 for those. Right. So we want to work out, we're going to need the upper bound for each of these, aren't we? Because we want the worst case scenario. The bags are all max heavy. Okay. So the upper bound is going to be equal to 30 sacks of potato, 30 lots of the upper bound of P, 25.5, plus 20 sacks of carrots, and again we're going to use the upper bound here, 7.55, aren't we? Worst case scenario. Okay, so the worst case scenario here is they're all at the heavy end of their range. So that would be 765 for the potatoes, and the carrots, 20 times 7.55, that's 151. Okay, so worst case scenario is that we add those together, plus 765, and that comes to 916. Okay. So the very heaviest it can be is 916, and that does not exceed the maximum load of 920. So can she definitely use her van safely in one journey? Yes. Van can be safely used. Okay, just make sure you actually answer the question. Next up, it's sequences. Make sure you're familiar with the 7 types of sequences that you're likely to get at GCSE Maths. You've got your 3 kind of number property ones, like square numbers, cube numbers, and triangle numbers. Plus you've got linear or arithmetic sequences, quadratic sequences, geometric sequences, and Fibonacci sequences. Okay, so you need to be able to generate next terms, term-to-term rules, position-to-term rules like nth terms, okay, for each of the different types. Okay. Let's crack on and look at the first question. So match each sequence to its description. One has been done for you. So we've got 1, 1, 2, 3, 5, 8. That's the Fibonacci sequence, isn't it? Where each term is the sum of the last 2, isn't it? So there we go. Next one, I've got 1, 2, 4, 8, 16, 32. Now that is, it's like a power sequence, isn't it? It's like powers of 2. So I think this one is going to have a common ratio. It's times 2 each time, isn't it? So times 2 times 2 times 2, which makes it a geometric progression because that's the one that has a common ratio. 1, 2, 3, 4, 5, 6. That's just an arithmetic progression, isn't it? It's going up in ones each time. Plus 1, and so on. 1, 3, 6, 10, 15, 21. I recognize that sequence. It's the triangle numbers. Yeah, so you just kind of have to recognize the patterns of those ones. 1, 4, 9, 16, 25, 36, that's the squares, and 1, 8, 27, 64, that's the cubes. Okay. Question 30, here are the first 5 terms of a linear sequence. We've got 9, 15, 21, 27, 33. Work out the nth term. Right, so to find the nth term of a linear sequence, all we really need to do first off is to find the common difference. So 9 to 15 is plus 6, as is 15 to 21 and 21 to 27. So I know a sequence that goes up in 6s, it's 6n, and 6n goes 6, 12, 18, 24, 30. Now our sequence, if you notice, each term is like 3 more than 6n. So our sequence then is going to be 6n plus 3. Okay, so that's my nth term, 6n plus 3. Question 31, here is a linear sequence, 46, 40, 34, 28, 22. Work out the nth term of this sequence. So this time it is going down in 6, isn't it? It's minus 6, minus 6, minus 6. So I know something that goes down in sixes. That's minus 6n. Minus 6n goes minus 6, minus 12, minus 18, minus 24, minus 30. Now we've got 46. So what would you have to add on to minus 6 to get up to 46? You'd have to add on quite a bit. You'd have to add on 52, wouldn't you? Okay, so I think our sequence is minus 6n plus 52, which you can write slightly more neatly the other way around as 52 minus 6n. Okay. Question 32, here's a linear sequence, 21, 23, 25, 27. Circle the expression for the nth term of this sequence. Well, this time it's going up in 2s, plus 2, and so on. So it's going to have something to do with 2n, which goes 2, 4, 6, 8. Now, our sequence goes 21, 23, 25, 27, which is, each one of those is 19 more than the 2 times table. So I believe we've got 2n plus 19. Have I got 2n plus 19 in the list? Yes, I do. It's that one there. A different sequence starts a, 2a minus 3, and so on. The term-to-term rule for this sequence is multiply by 2 and subtract 3. Now, the fourth term of this sequence is 35. Work out the value of a. Okay, so you've got like a two-step function, isn't it? You've got your number. You are multiplying by 2 and then you are subtracting 3. Okay, so if our fourth term, u4, is 35, so u4 is 35, then if 35 came out, what went in? So if I subtract something, subtract 3 from something and get 35, it would have been 38. And then if I'd have timed something by 2 and got 38, I think it would have been 19. So u3 would have been 19. Okay, and then just repeating that process again. If I have a number and subtract 3 and get 19, it must have been 22. If I had a number and I times it by 2 and I got 22, it must have been 11. So u2 is 11. And then finally, what would I have to have started with if I ended up with 11? So adding 3 would give me 14, dividing by 2 would give me 7, wouldn't it? So u1 is 7. And we were told that u1 is a. So there we go, a is 7. Question 3, here are the first 4 terms of a quadratic sequence, 11, 26, 45, 68. Work out the expression for the nth term. Now, there are 2 schools of thought on how to do these sorts of question. There's kind of a easy-ish method that doesn't make a lot of sense, and a slightly more algebraic method that makes sense but might be slightly longer. I don't know, I quite like it. So I'm going to show you both ways because I'm feeling generous today. So they're kind of like the nonsensical but kind of easy way is that you look at for the common second difference. This sequence is going up in 15 and then 19 and then what's that, 23? Okay, so the differences of the differences are plus 4 then, isn't it? Okay, so what you're meant to do with this nonsensical method is you take that common second difference of plus 4, you divide it by 2, and that gives you 2n squared then, isn't it? So if you think about 2n squared for the first 4 terms, when n is 1, I'm going to get, so if I've got 2n squared, when n is 1, 1 squared is 1 times 2 is 2, 2 squared is 4 times 2 is 8, 3 squared is 9 times 2 is 18, and 4 squared is 16 times 2 is 32. Okay, and if you then subtract those numbers from your original sequence, then we're going to get 11 subtract 2 is 9, 26 subtract 8 is 18, 45 subtract 18 is 35, 27, and 68 subtract 32 is 36. Now you can see this is a linear sequence. It's going up in 9s. Actually, it's just 9n, isn't it? So this is the sequence 9n. Okay. So if I take 2n squared away from my original sequence, I end up with 9n. Therefore, un is going to be 2n squared plus 9n. Okay, those two things together make your sequence. Now, it's a good idea just to double check. So, you know, u1 is 2 lots of 1 squared plus 9 lots of 1. Is that true? 2 lots of 1 squared is 2 plus 9 is 11. That works. And u2 is equal to 2 lots of 2 squared plus 9 lots of 2. So that's going to be 4, 8 plus 18. That is D26. So it seems to work. Okay, right, so that's the nonsensical, easier way, and that gives me 2n squared plus 9n. The other way of doing it is using the fact that un is going to be a quadratic, and a quadratic looks like ax squared plus bx plus c, doesn't it? Okay, so for u1, the first term, well, I suppose I should write it with n's rather than x's. Let's just rewrite that with an squared plus bn plus c. Now, if for u1, the first term, n is 1, isn't it? So a times 1 squared is just a, plus b times 1 is just b, plus c. So the first term is going to be a plus b plus c. The second term, u2, is going to be 2 squared, 4 lots of a, 4a, plus 2b plus c, isn't it? Okay, and then we need a third one. Let's do u3. u3 is going to be 3 squared is 9, it's going to be 9a plus 3 lots of b, which is 3b plus c. Okay, so we've got 3 equations here in 3 unknowns. Okay, and we're going to just solve them simultaneously then. Because we know u1 here, the first term is 11, and we know u2, the second term is 26, and we know that u3, the third term, is 45. So we can form 3 equations in 3 unknowns here. We can say that u1 is 11, u2 is equal to 26, and u3 is equal to 45. Okay, and then you can solve these by taking various combinations of equations away from each other. So if I do like u2 minus u1, that's going to be 4a take away a, which is 3a, 2b take away b, which is b, c take away c, which cancels, and 26 take away 11 is 15. Okay, and if I do the same thing for u3 take away u2, I'm going to get 9a take away 4a is 5a, 3a take away 2b is b, and c take away c is 0, and 45 take away 29 is 19. Okay, so now I've got 2 more equations. But now I've only got 2 unknowns. I've got 3a plus b is 15 and 5a plus b is 19. So we can solve these 2 simultaneously just by subtracting one from the other. I'm going to subtract uphill because I've got the bigger one on the bottom. So 5a take away 3a is 2a, b take away b is zilch, and 19 take away 15 is 4. So I've got 2a is 4, so a must be 2. Subbing that back into our other value, our equation, 3a plus b is 15. That means that 3 lots of 2 plus b is 15. So that means b must be equal to 9. And then subbing 2 and 9 back into u1, I've got a plus b plus c is 11. So 2 plus 9 plus c is 11. Well, that means c is equal to 0. Okay, so then subbing those 3 values in back into our original equation, an squared plus bn plus c for the nth term, I know that a is 2, b is 9, c is 0. So that gives me the nth term, 2n squared, to 2n squared plus 9n plus 0. So you see I get the same result. Now which one you use, I don't know, you know, if you at the first glance the algebraic one is very complicated, but actually the maths that you do is the same no matter what the sequence is. You always do the same thing. So I always get u1, u2, u3 in terms of a, b, c. They always look the same. When you subtract them, you always get the same. And so it's just you've got slightly different numbers each time for a different sequence that you can go on to solve. I quite like the algebraic method. The other method doesn't make sense to me, and people forget it quite easily. But if you're good at algebra, then the second method is good. If you don't really like algebra, maybe stick with the first one. Right, question 34. Work out the expression for the nth term of the quadratic sequence 2, 17, 40, 71. Give your answer in the form a squared plus bn plus c, where a, b, and c are constants. Okay, so yeah, same thing, same deal. So we could either solve it by finding the common second difference, or we could do it algebraically. I might just do it by the easy way because it's quicker. So the difference there is 15, the difference there is 23, the difference there is 31. So the difference of the differences is 8 and 8. Okay, so the squared term then, half of 8 is 4, so I'm going to get 4n squared then, aren't I? 4n squared for my nth term part. So then 4n squared, when n is 1, 4n squared is going to be 1 squared times 4 is 4. When n is 2, n squared is 4 times 4 is 16. When n is 3, I'm going to get 9 times 4, which is 36. And when n is 4, I'm going to get 16 times 4, which is 64. Then subtracting, I get 2 subtract 4 is minus 2. 17 subtract 16 is 1. 40 subtract 36 is 4. And 71 subtract 64, that is 7. Okay, so this is a linear sequence. It's going up in threes, isn't it? Plus 3, plus 3, plus 3. So I know something goes up in threes. It's 3n. 3n goes 3, 6, 9, 12. I've got minus 2, 1, 4, 7. So each one of those numbers is my sequence minus 5. So this part here then must be 3n minus 5. Okay, so my entire sequence, nth term an squared plus bn plus c, is going to be equal to un is equal to 4n squared plus 3n minus 5. It's basically that bit with that bit on the end. Okay. Next up, we're going to look at parallel and perpendicular lines. So we should know how to find the gradient of a line from its equation. Just need to rearrange it in the form y equals mx plus c and read out m. And you should know how to find the gradient of a perpendicular line. You should know that one is the negative reciprocal of the other. If you know those two things, you should be good to go. Let's try out these questions. So, question 35. Show the lines y equals 3x plus 7 and 2y minus 6x equal 8 are parallel. Do not use a graphical method. Okay, so we just need to show the gradients are the same, don't we? So for y equals 3x plus 7, the gradient is just that number there, isn't it? So m1, the gradient is equal to 3. And for the second equation, 2y minus 6x equals 8. Rearranging, that's going to give me 2y equals 6x plus 8. And dividing everything by 2, I'm going to get y equals 3x plus 4. So then the gradient of this line is that value there again in front of the x. So m2 is equal to 3. So we found that m1 equals m2. Therefore, they are parallel. Okay. Right. Is point minus 5 minus 6 above, below, or on the line y equals 3x plus 7? Tick one box. Okay. So what I'm going to do is I'm going to take this value here for the x coordinate. I'm going to sub it in here. I'm going to work out the y value. Now, if the y value is minus 6, it's on the line. If the y value is more than minus 6, it's going to be above the line. And if the y value is less than minus 6, it's going to be below the line. Okay? So what is 3 lots of minus 5 plus 7? 3 lots of minus 5 is minus 15 plus 7. That's equal to minus 8, is it not? So minus 8 is less than minus 6 and therefore lies below the line. So I'm going to tick below. Question 36. The line y equals mx plus c passes through the point 4, 3. It is parallel to the line y equals 5x plus 6. Work out the values of m and c. Right, so m2, the gradient of the line it's parallel to, is 5. Parallel, so m1 equals m2, which is equal to 5. Okay, so we know that the gradient is 5. Let equation be y is equal to 5x plus c, where c is our y-intercept that we're trying to find. We know the equation, or the line, passes through this point up here. Look, it passes through 4, 3. So we know it passes through 4, 3. So if we sub both those values into our partial equation, y equals 5x plus c, then the only thing we won't know in there is c, so we can then go and find it. So the y coordinate is 3. and that's equal to 5 lots of the x coordinate, which is 4 plus c. So 3 is equal to 20 plus c, so c must be equal to 3 minus 20, it's minus 17, isn't it? Okay, so c is minus 17 and m is 5. Question 37. Minus 3, 10 is a point on the line L. 4, 0 and 6, 10 are points on the line M. L and M are parallel. Work out the equation of line L. Give your answer in the form y equals mx plus c. Okay. So we can find the gradient of our line M because we've got 2 points that lie on it. Okay, so if we can work out the change in y and the change in x and divide them, then we should get our gradient. Okay, so m1, the gradient of m, that's going to be y2 minus y1 over x2 minus x1. This is a very handy formula. So if this is x1, y1, and this is x2, y2, it's just a handy formula to sub in your coordinates to find the gradient. So y2 is the y coordinate of the second point, which is 10. y1 is the y coordinate of the first point, which is 0. x2 is the x coordinate of the second point, which is 6. And x1 is the x coordinate of the first coordinate, which is 5. So I get 10 minus 0 over 6 minus 4. That's 10 over 2. So that means the gradient is 5. Okay? So m1 is 5. And we know that m2 and m must be also 5 because they are parallel. Okay? So we know the equation of L is gonna have 5x in it. Okay, so equation of L of form y is equal to 5x, because we know the gradient is 5 plus c. Okay, now we know the point that lies on the line is minus 3, 10. So we can say passes through minus 3, 10. So subbing those values in, very much like last time, the y coordinate is 10, and that's 5 lots of the x coordinate, which is minus 3. That should give me c then, shouldn't it? So 10 equals minus 15 plus c. So c then is equal to 10 plus 15. It's going to be 25. Okay. So then what is the answer? The answer is y is equal to 5x plus 25. Question 38, points P, Q and R, where we've given R, it's 8, 22, form a triangle. PQ is a horizontal line with P on the y-axis. Angle PRQ is a right angle. The gradient of PR is 2. Work out the coordinates of Q. Okay, it's interesting. Right, so we know the gradient of PR. PR has got a gradient of 2. So if I did change in y and change in x, I'd get a gradient of 2, wouldn't I? Okay, so then the equation of the line PR is going to be of form y is equal to 2x plus c, because we know the gradient is 2. Okay, and we know it passes through 8, 22, doesn't it? That point R. And so if we sub those in, we get 22 is equal to 2 lots of 8 plus c. 2 lots of 8 is 16. So c then must be equal to 22 minus 16. C is 6. And therefore, PR is y is equal to 2x plus 6. Okay? Right, so that point there must be 0, 6, mustn't it? Because that's the y-intercept. So we know one coordinate of Q now. It's going to end in 6, because remember that PQ is a horizontal line. Now we just need to find the x coordinate. Right, so what do we know? We know that that's a right angle, and therefore RQ is perpendicular to PR. So RQ is perpendicular to PR. That's just like a weird math shorthand for perpendicular. It's like a little right angle with AR written after it. Right, so RQ is perpendicular to PR, and that means that their gradients, M1, M2, when you multiply them together, give you minus 1, because one is the negative reciprocal of the other, and therefore M2 is going to be minus 1/2. Okay, so taking the gradient of the other line, flip it over and sticking a minus sign in front of it, you're going to get minus 1/2. Okay, so therefore we know that the equation of RQ is of form y is equal to minus 1/2 of x plus c. Okay, so now we need to find the c value of our new equation. Just draw a line down there so I don't get confused with what's what. So then we know it, again, it passes through the same point, doesn't it? It passes through 822. Both lines meet there. So if you sub those values in, I'm going to get 22 is equal to minus 1/2 of 8 plus c. Now minus 1/2 of 8 is minus 4. So that makes c equal to 26, isn't it? And therefore equation is y is equal to minus 1/2 x plus 26. Okay, so now we're almost done because we know what the y coordinate is and we know everything else about the equation now. So when y is equal to 6, because we know it has to be 6, subbing that in, that's going to give me might be a little bit off the line there. So that's going to give me y, or 6, sorry. That's going to give me 6 is equal to minus 1/2 x plus 26. So taking the 1/2 x to the other side and 6 to the other side, I'm going to get 1/2 x is equal to 20. So x then is going to be twice that. It's going to be 40. Okay, so that's going to be 46 there. So that's my coordinate then. X coordinate is 40, y coordinate must be 6. Now that question is quite long, but actually we're just doing the same thing 3 times over basically, aren't we? So you know, if you know how to do that one thing, you can do that one thing 3 times. So yeah, long but same. Right, question 39. This is a bit more interesting. We've got a circle thrown in for good measure here. 4, 8 is a point on the circle centre 0. That's that point up there, look. The tangent at 4, 8 intersects the x-axis at P. Work out the x-coordinate of P. Okay. So what we're going to have to do here is find the equation of the line, of the tangent, and then work out the value of P. Because we know the y-coordinate is going to be 0, isn't it? Because it lies on the x-axis. So if we find the equation, we sub 0 in it for y, we should find the value of x, and then we've got our coordinate. All right. So how can we find the equation of the line of that tangent then? Well, we know 2 points on this line, the radius of the circle. So because we know that point there is 0, 0, and that point there is 4, 8, we can work out the gradient, and we've got a point on it, so we can find the equation of that line. Very easy. And then once we've got that, then we can find the gradient of the other line because it's perpendicular. This is a right angle. Okay. So let's find out the gradient of the radius first. So gradient of the radius, I'm going to call that m1, and that's going to equal to changing y from 8 down to 0 and changing x from 4 down to 0. That's 8, that's 4, isn't it? So m1 is going to be the change in y, 8, divided by the change in x, which is 4. Give me a gradient of m1 is equal to 2. Okay, so tangent is perpendicular to radius, so m2 times m1 is equal to minus 1, so m2 is going to be the negative reciprocal of 2, which is minus 1/2. Okay, so we know the gradient of our line going down to P now is got a gradient of minus 1/2, and we know a point that it passes through 4, 8. So therefore tangent has equation of form y is equal to minus 1/2 x plus c, and we know it passes through the point 4, 8. So subbing those two values in for x and y, we've got 8 is equal to minus a half lots of 4 plus c. So minus a half lots of 4 is minus 2. So 8 equals minus 2 plus c, and that makes c equal to 10 then, doesn't it? Okay, and therefore equation of tangent is y is equal to minus a half x plus 10. Okay, so now we've got the equation of the tangent. We want to find the coordinates of the point P, and we already know that the y coordinate must be equal to 0 because it lies on the x-axis. So when y is 0, what's the value of x? So I've got 0 equals minus a half x plus 10. So taking the minus half x the other side, I've got a half x is equal to 10. So x is going to be equal to 20. And therefore, P is the coordinate 20, 0. Okay? Again, long, but we're just doing the same things over and over again, aren't we? You know, finding equations of lines, finding points on lines. It's all actually fairly straightforward stuff. Okay. Next up is advanced trigonometry. Now, I made this paper before paper 2 came out, and you'll remember my top 10 topics for paper 2 also had advanced trigonometry on it. Now, these top 10s are not really predicted papers, they're just top 10 topics that appear on these papers, and I make them before the papers come out. So it's not a predicted paper. So if you know that trigonometry involving the sine rule, cosine rule, and area of a triangle came up already, then probably it won't come up again. But you can well have the sine rule in paper 1 and the cosine rule in paper 2 tested, or it may even come up twice. So always worth practicing, even if it has come up in paper 1 and 2, although it does make it a little bit less likely that it will appear again. But like I say, if you've done sine rule already, then you could easily have the cosine rule come up or the other way around. So yeah, let's crack on and do this. Right, first up with the sine rule, cosine rule, you have to kind of work out which one you got. So here I've got an angle over here and an x over here that I want to find that's opposite it, and I've got a 14 here and an angle here that I know. Okay, so this involves opposite pairs, and opposite pairs is the sine rule. Okay, so if you can find two opposite pairs in your diagram, then you've got the sine rule, and that's the one you need. Okay, so writing down the sine rule, now you can write the sine rule either way up, either with the angles at the top and the sides at the bottom, or the other way around. It's easiest to put it the way around that you're going to use it. So here we want to find a side, so I'm going to write it with the sides on the top. So A over sine A equals B over sine B. Okay, so subbing in then, we get A is x, isn't it? So x over sine, well, the thing opposite the thing opposite x is 56 is equal to B. In this case, B is 14 over the sine of B, which is 30, sine 30. Okay, so rearranging for x equals 14 sine 56. This just moves up here, doesn't it? Change sides, change signs. Gonna bundle that one over the top right, and then everything else stays where it is. So I get x equals 14 sine 56 divided by sine 30. Tappity tap that into the old calculator. 40 sine 56 divided by, just take care of brackets when you've got more than one, divided by sine 30. Well, sine 30 is a half, isn't it? I know that already. That comes out to be 23.2. X equals 23.2. Now, before I move on, well, it's good to have a sanity check here. Does that look about right? It's quite long, 23.2. It's about half as long again as the other one, but it's not outrageously long. I think I'm going to go with that. Remember, like 56 is a bigger angle, so you'd expect it to be a longer side. Yeah, so I'm going to go with 23.2. Doesn't look too crazy there. Okay, question 41. Again, we've got opposite pairs going on here, haven't we? Look, this one matches up with this one. This one matches up with this one. So again, if you're picking between sine rule and cosine rule, then you know this one is going to be a sine rule question, isn't it? Because it's about opposite pairs, and cosine rule isn't. Cosine rule is about three sides. We'll talk about that when one comes up. But yeah, but this time I need to find an angle rather than the side. And I did say you could write the sine rule either way up, and because I want an angle this time, it makes sense to write it with the angles on the top. So sine A over A is equal to sine B over B. That's the general sine rule equation. And then subbing in for our particular problem here, that means sine x over the thing that's opposite x, which is 6, and that's going to be equal to sine the other one, sine 125 divided by the thing that's opposite 125, which is 14. Now I want to try and get x on its own, so I'm going to rearrange, aren't I? We're just going to cross multiply that 6 up there. So then sine x is equal to 6 sine 125 over 14. And so then x is going to be the inverse sine of that McGubbins then, isn't it? So 6 sine 125 over 14. So quite a complicated thing to type into the calculator. So shift sine to get the inverse sine. Then I'm going to write this thing as a fraction, I think. So I'm going to use the fraction key. I'm going to write the 6 sine 125 at the top, and then I'm going to come down and I'm going to write the 14 at the bottom. I'm going to remember to close the bracket so it's all neat and tidy. Okay, so and that apparently is 20.55. So if I was to round it off to 3 different figures, it's going to round up one, isn't it? And that's going to be 20.6. Now, if I find an angle, it's a degree then, isn't it? So 20.6 degrees. Now, does that look right? Again, before I move on, just kind of try and imagine that in the place up there. Does it look about right? 20.6 up there? Well, it's a kind of a thin angle up there, isn't it? So it does kind of look good in that position there. So I reckon that's right. 20.6 is my final answer. Good. Question 42. Now, we don't have two opposite pairs here. We've got x going with 55, but then I've got two sides and no angle to match them up with. So this is not the sine rule. I did say cosine rule is about 3 sides, and you can see here I've got 3 sides, 1, 2, 3. So if you've got 3 sides and you want an angle, then it's the cosine rule, isn't it? Okay. So writing down the cosine rule, it kind of starts off like Pythagoras theorem, c squared equals a squared plus b squared. It starts off from like Pythagoras theorem because that's what it's derived from. So it's kind of an extension of Pythagoras theorem actually. So yeah, c squared equals a squared plus b squared, and then you minus, and then these two letters here get repeated with a 2 in front of it, so 2ab, and then you have a cos of the thing that's at the front, okay, is also at the back. So that is 2ab cos c. Okay, so that I kind of remember the pattern. So I remember like it's c squared equals a squared plus b squared. So it starts off like the cosine, like the Pythagoras theorem. Then the a and b repeat, and then the cos on the end is the letter is the same as the letter you started with. But in this particular case, it's the angle we want to find, isn't it? It's this bit over here that we're trying to evaluate. We're trying to evaluate c, the angle there. Well, I suppose I'm going to call it, if I called this c, then this would be side c. And then if this was a, this would be side a, and if this was b, this would be side b, like that. Okay, so I want to find that angle up there at c. So I'm going to have to rearrange this first to make c the subject. So taking that minus 2ab cos c to the other side to make it positive, so I get 2ab cos c, and moving the c squared over to the other side, I'm going to get a squared plus b squared minus c squared. Okay, so I've just kind of shimmied that over there, and I've taken this bit, all of this, and I moved it over here. Look. Okay, so change sides, the minus 2ab cos c became positive and the c squared became negative. And then what I'm going to do is I'm just going to take this part that's in front of cos c, and I'm going to divide both sides by it, so it'll end up moving down there. Look. So I'm going to get cos c is equal to a squared plus b squared minus c squared over 2ab. Okay, so that's the formula, and I just need to carefully sub into it now. Okay, so I already kind of labelled up my triangle ABC, so it should be a little bit easier to sub in. So a squared is going to be this 40 over here, 40 squared, plus b squared, that's the 32 squared, minus c squared, that's going to be the 55. Okay, and that's divided by 2 times a, which is 40, times b, which is 32. Okay, so, and then we need to take the inverse cosine of that then, don't we? So then c is equal to, again, it's going to be quite a thing to type into the calculator. I'm going to press the shift cos, so I get the inverse cosine. I'm going to use the fraction key. On the top line, I'm going to do 40 squared plus 32 squared minus 55 squared. And come down to the bottom line, and I'm going to do 2 times 40 times 32. Not sure if it matters on this calculator if I close the bracket or not, but I'll do it anyway. And that comes out to be 99.0. 99.0. Does that look about right? Well, in terms of the diagram it does. That looks like it's just a little bit more than a right angle, doesn't it? So 99.0 looks good in that shape. So yeah, I'm happy with that. 99.0. 43, work out the length BC. So BC is the side opposite A, so let's call it A. Now this is another cosine question, a cosine rule question, because even though I don't have 3 sides, I've got 2 sides and an included angle, but I want the 3rd side. So either you've got the 3 sides or you want 3 sides, then it's the cosine rule. Okay, that one is little a because it's opposite side A, so this one is going to be little b, and this one is going to be a little c. So I need to write the cosine rule so it's in terms of a, because a is what I want to find. So a squared equals b squared plus c squared. Remember then it was these two ones get repeated then, don't they? So it's going to be minus 2bc, repeating the b and the c that came before, and then it's the cosine of the letter you started with. So 2bc cos a in this case. So again, look, I remember the pattern, so I can just reformulate it for whatever given letters I've got to work with. Okay, so then carefully then subbing into that equation. So b is 45, so that's 45 squared, plus c, which is 60 squared, minus 2 lots of b, which is 45, and c, which is 60, times the cos of a, which is 110 degrees. Okay, so that's what needs to be typed in. Again, a long one, take care. So 45 squared plus 60 squared minus 2 times 45 times 60 times the cos of 110, close bracket, equals. Now that looks a little bit horrendous. That's 7,471.9, but remember that's a squared and I want a, so not time to panic just yet. Okay, so then a is going to be the root of that. I've written it down to 5 significant figures, but I'm actually going to use the full calculator display to work out my answer. So I'm just going to use root answer equals, and that comes out to a more respectable 86.4. So that's equal to 86.4, and I think 86.4 looks fairly decent in that triangle, doesn't it? Because it's the longest side, clearly longest side because it's opposite that obtuse angle. 45 and 60 and 86 doesn't look dreadful. I think that looks all right. I'm gonna stick with that. 86.4. Question 44. The diagram shows a logo. ABE and DCE are congruent triangles. BCE is a sector of a circle center E. Show that the area of the logo is 510 square centimeters to 2 significant figures. Okay, so to work out the area of this logo, we're going to have to break it down into the various parts, aren't I? So I've got this triangle here. It's a non-right angle triangle. Okay, and that is congruent, so exactly the same shape and size as this one. So that means I just need to find one and then double it up, and I've got both of them, haven't I? Okay, so it's going to be twice the area of one of those. And then I need to find the area of the sector that lies in between them here. Okay, so it's a a sector and two identical non-right angle triangles. So a little bit of work to do, but you know, we can do it, I'm sure. Right, so let's break this down. Let's do the triangle first. So triangle ABE. Now this is a non-right angle triangle, so I can't use half base times height because I've got no right angle. But what I do have is two sides and an included angle. So I can use the trigonometric version of the area of the formula, of area of a triangle formula. So, and if you remember, that is half AB sine C. Okay? So A and B are the two sides that you know, and C is the angle between the two of them. Okay, so that is going to be a half 26 times 15 times the sine of 38. Okay, so what's that? So tapping that carefully into the old calculator. So half times 26 times 15 times the sine of 38. Okay, now that comes to 120.05. I'm going to just round that off to 120.1. Okay, and then I've got the area of the sector. So sector, what's that? BEC. BEC, and that has an area. How do we find the area of a sector? It's the angle at the center, 108 over 360, times the area formula of a circle, pi r squared. Now, what is the radius? Oh no, we don't have the radius. Okay, so we have got a little bit more work to do first, because we need to find that radius before we can go on and find the area. So it looks like we're going back to the triangle ABE, and we're going to be using the cosine rule then to find the third side given the other two in the angle, aren't we? So in triangle ABE, what we're going to do, we're going to use, well, if that's side angle A up there, then this is side A down here. If that's angle E, then this is side E, and if that's angle B, this is side B. So I've got sides A, B, and E, and I want side A. So I'm going to start with A at the front of my cosine rule. So A squared equals B squared plus E squared minus 2BE cos A. Just remembering the pattern that we talked about earlier, that B repeats, E repeats, and it starts and ends with the same letter. Okay? So yeah, that's the formula. So then subbing in carefully, B is 15, 15 squared, E is 26, 26 squared, times, minus 2 lots of 15, lots of 26, and then that is cos, going off the edge of the page on here, let me just budge it over a little bit, cos of the angle, which is 38 degrees. Okay, so that's what we need to type into the calculator, obviously very carefully. So then I'm going to press the square root this time, so I don't have to faff around in between. So I'm going to put root and then 15 squared plus 26 squared minus 2 times 15 times 26 times the cos of 38. Close bracket. Boom, what's that then? That's 16.9 to one decimal place. So A is 16.9. So then that's going to be my radius, isn't it? So now I can come back to my area formula down here and say that that's 108 over 360 times pi times 16.9 squared. What did I write? 19? 16 point, what did I write to? 16.9 squared. Okay, so it's still in my calculator. So I'm just going to use that same value. So I'm going to do 108 divided by 360 times pi times answer squared. Okay, and that comes out to be 269.9. 269.9. So then the total area is going to be 2 lots of the area of the triangle, which was 120.1, plus the 269.9, which we found the sector to be. Okay, so then adding on 2 times 120.1, that comes out to be 510.1. So 510.1, and that's going to be in centimeters squared then, isn't it? Oh, show that the area of the logo is 510 centimeters to 2 significant figures. So I can just say, yeah, that's roughly 510 then, isn't it? Okay, good. Good job. We did it. Question 45. A ship sails from P to Q and then from Q to R. Q is 12 miles from P on a bearing of 80 degrees. R is 28 miles from Q on a bearing of 155 degrees. Work out the direct distance from P to R. Okay, so it may not look like it immediately, but this is another cosine rule question, because once I draw that little extra line in here, we're trying to find that length PR, aren't we? Which is the third side of a non-right angle triangle, of which we know the other 2 sides. Okay, so we need to find angle Q first, and then we should be able to find that side Q there quite easily. I'm going to call this one up here R, and then this one P, because they're opposite the point, the vertices P and R, and that's how we label these things up. Now, what is that angle there at Q? I really need that one if I'm going to use the cosine rule. Well, I've got a pair of parallel lines here. These lines are both pointing north, okay, and I've got a line crossing them going up here. So that means that this angle here, the 80, and this angle up here are what we call supplementary, aren't they? They're the co-interior angles of those two. So that one there is going to have to add up with 180 with 80. So that one's going to be 100. And because I've got the bearing of R at 155, those 2 angles add up to 255. So Q then, angle Q, this bit here that I need to find, is going to be 360 minus the other 2 angles then, isn't it? Okay, so 255 away from 360, that leaves 105 degrees. Okay, so we're going to use 105 degrees as our angle. So now we're ready to crack on with using the cosine rule. So formulating it in terms of the sides I've been given, Q squared equals P squared plus R squared minus 2PR cos Q. So again, remember on our pattern that the letters repeat, P and R repeat, and then it ends and starts with the same letter, like that. We can then just sub into our corresponding version of the cosine rule. So P is 28, 28 squared, plus R, which is 12, 12 minus 2, lots of 28, lots of 12, cos, and then Q, we just worked out to be 105, didn't we? 105. Okay. Right, so again, I'm going to remember this time to press the root key first, so I don't have to do more than one thing. So Q is going to be the root of 28 squared plus 12 squared minus 2 times 28 times 12 times the cosine of 105 degrees, close bracket. Looks good. Right, what's that come out to be? 33.2. 33.2. Does that look about right? Yeah, it's longer than, it's definitely the longer side, isn't it? 33.2 looks about okay. So 33.2 miles. Work out the direct distance from P to R. It's 33.2 miles. Question 46. The volume of a pyramid is 1/3 times its area of its base times its perpendicular height. VABCD is a regular based pyramid with a volume of 336 cubic meters. X is the center of the horizontal base directly below V. So I said regular, it said rectangular actually. Okay, so what do we need to do? Work out the angle between VB and the base. VB and the base. So we're looking for this angle here then, aren't we? This angle in this triangle BXV. Okay, now that angle there at X is a right angle. Now if we want to work out that angle, we're going to need to know at least two things inside this triangle that we don't currently know. Either, well, basically we're going to need two sides, aren't we? We're going to need to find two sides of this shape. Now we've got the formula for the volume, so I guess what we can do is we can use that to work out the perpendicular height of the shape, and that will give us xv. But we'll also need to find another side of the triangle, like bx or something like that. And we can probably do that with Pythagoras theorem. So that's what I'm gonna do then. Let's form a little right angle triangle by drawing a line coming from here down to here at a right angle. So this triangle here then, I can work out Pythagoras theorem from, because I know that the distance from there to there, look, is going to be 7. It's half the 14, and the distance from there to X is going to be 4, isn't it? Okay, so then I can work out XB from that then. So I'm going to say XB, or BX, I don't know which way around I'm going to write it, XB is equal to, or XB squared is equal to 4 squared plus 7 squared using Pythagoras theorem. So that's 16 plus 49, which adds up to 65. So then XB then is the root of 65. I'm just going to leave it as the root of 65 for now. Just add that into my diagram. That is root 65. Okay, so I know one thing in the triangle now, BXV, but I need to know another thing. The next thing I want to find is this length. Okay, so I found this length. So let's find another thing, and then we can use trigonometry in that triangle to find the angle. Okay, so let's find XV. Now I can do that because XV is the perpendicular height, and I know the volume. The volume of the pyramid was given there, and I can work out the area of the base with not too much problem, can't I? So what is the area of the base? Well, the area of the base is going to be 14 times 8, isn't it? So I can work out the area of the base fairly easily. So let's say the volume is equal to 1/3 times the area of the base times the height. Well, I'm just going to call it times XV, because that's the side I'm trying to find, isn't it? XV. So volume I know is 336. And that's equal to 1/3 times the area of the base, which was 14 times 8, and then that's times XV, the side I'm trying to find. Okay, so then rearranging, then XV is going to be 336. That third, if I times through by 3, it will disappear, and I'll get a times 3 up here, and then I'm going to divide through by the 14 and the 8 like that. So I've got XV, the height of the pyramid, is going to be 336 times 3 divided by 14 divided by 8, and that comes out to be 9. So that's equal to 9. So XV is equal to 9. Okay, so that side there is then 9. So now I know two sides in this triangle. It's a right angle triangle, so I can then go and find the angle, aren't I? So take in triangle VXB. So in this triangle here, look. So that's X, that's V, that's B. I want to find that angle there. I know that's 9. I know that's root 65. But I also know that this is the opposite and this is the adjacent. So think about our rules for trigonometry. SOHCAHTOA. Which one is about the opposite and the adjacent? It's this one here, the tangent, isn't it? So tan theta is equal to op over adj. So in this case, it's going to be the opposite, which is 9, divided by the adjacent, which is the root of 65. So then theta, the angle, is going to be the inverse tangent of that fraction, and then the 9 over root 65, whatever that is. Okay, so then typing that into the calculator, shift tan 9 over the root of 65. What is that then? Close bracket. Don't know if it matters. Let's do it anyway. 48.1 apparently. 48.1, and that's our answer then. That is the angle we're trying to find, isn't it? That is the angle between VB and the base. Okay, so it's 48.1. Next up, we're looking at algebraic fractions. Now, students often find these puzzling, but I don't really know why. They just behave the same way as adding, subtracting, multiplying, dividing normal fractions. So if you know how to do it with normal fractions, you just do the same thing. So first up, question 47, you've got a subtraction of fractions going on here. Now, if you've got subtraction, I don't know if you noticed the numerator one is a multiple of the other. So like if you had like a half and you were subtracting an eighth, the first thing you would do is you would change the denominator, wouldn't you, on that half, because the 8 is 4 times as big. So you'd multiply that up by 4, and then you change that into 4/8 minus 1/8, and it'd be super easy. It'd be 3/8. Now we're going to do the same thing here. I've got a as one of my denominators and 4 lots of a on the other one. Okay, so the denominator of the second fraction is 4 times bigger. Okay, so then the common denominator is going to be 4a. So all I really need to do is times this one by 4. So I've got the same denominator for both. So that's going to be 6 times 4, which is 24 over 4a, minus 11 over 4a, and 24 minus 11 is 13 over 4a. Okay, and that's my answer, 13 over 4a. So my top tip on algebraic fractions is, not sure what you're doing, think about what would I do if it was numbers, and just do the same thing, then you'll get it right. Okay. Right, question 48, simplify 25a over 8 times 2a over 5. Now again, fraction multiplication, you look to cancel top and bottom, don't you? And then you multiply. That's what I would do. So we're going to do the same thing here. Can I just see if we can simplify it first? So can you see I've got an 8 and a 2 there, both of those divisible by 2. So I can make that 4, and that one cancels. And also I've got a 25 and a 5 there. So if I cancel the 5 into the 25, that gives me 5 and 1. So then multiplying through, 5 times a, that's 5a. And 4 times 1 is 4, so that's my answer. It's 5a over 4. Okay. Question 49, show that x minus 5 over x minus 2 minus x plus 5 over x plus 2 simplifies to that thing there. Okay, so again we got fraction subtraction. Looks pretty horrible to start with, but we know how to subtract fractions. The first thing we're going to do is come up with a common denominator. Now when you've got two different numbers in your fractions, let's say I had like a half minus a third, then what's the common denominator? The common denominator is going to be it's going to turn them both into 6s, aren't you? So if you could make the 6 the common denominator, by multiplying these two things together, you'll get the new common denominator. So my common denominator of x minus 2 and x plus 2 is going to be x minus 2, x plus 2. That's what it's going to be. Okay, so we've just got that and that, which we push together and make that and that. Okay, now if we were doing half minus a third, at this point I'd then be multiplying back, wouldn't I? I'd be multiplying this one back by the 3, the number that's there, and this side I'd be multiplying by 2, which is the number here. I'm going to do the same thing here. So this thing I've got up here, x minus 5, I'm going to multiply with the x plus 2. So x minus 5 times the x plus 2. So that was what was already there, and that's the denominator of the second fraction. And then I'm going to be subtracting what's already there, which is x plus 5, multiplied by the denominator of the other fraction, and the other fraction has the denominator of x minus 2, the yellow denominator. Okay, so that's where all the bits come from. So now it's just a matter of multiplying out brackets, collecting like terms, and all that McGubbins. So let's do that then. So on the numerator, I've got x minus 5x plus 2. So multiplying that out, I'm going to get x squared minus 5x plus 2x minus 10 from the first two brackets. And then I'm going to do minus. I'm just going to put all this in brackets to start with, because I don't want to have to deal with the minus sign at the front as well. So let's just do FOIL on the second bracket, first outside, inside, last. So that's going to give me x squared minus 2x plus 5x minus 10. Okay, that's the numerator. Now over to the denominator. That's a little bit easier. I've got x minus 2, x plus 2, so that's just the difference of two squares. I might just leave it for now in brackets. I might find later that I can cancel those into something, so I'm just going to leave that as it is for now in factor form. I think that's going to be more useful to me. Looks like there was a typo on my version of this sheet. I'll correct it for yours. I think that's meant to be a plus, otherwise it doesn't work the way they want it to work. So if that's a plus there, then collecting like terms now, I'm going to get x squared and x squared, which adds together to give me 2x squared on the top. And then I've got minus 5x plus 2x minus 2x plus 5x. I don't know if you notice, they're just the same terms, but with the signs switched around. So the minus 5 and the plus 5 cancel, and the plus 2 and the minus 2 cancel. And then I've got minus 10 and minus 10, which makes minus 20. Okay, and then that's all over x minus 2x plus 2. Now I'm not going to have anything, I think, to cancel at the bottom, so I'm just going to go ahead and multiply that out. Now that's a difference of two squares, isn't it? So I know I'm going to get x squared minus 4 there, just because I know my difference of two squares. Okay, and then comparing that with the top, I've got 2x squared minus 20. That is in the form of ax squared minus b. A is 2, b is 20. And I've got x squared minus 4 on the bottom. So that's good. Okay, so that was a bit confusing. I was sitting there thinking, this is not going to work. What's going on? But yeah, I think it was a typo on my sheet. So I'll go back and correct your version so you don't have that same problem. Question 50, simplify fully 2 over x plus 1 plus 7 minus 5x over 3 plus 4x. Okay, so now it wants to give us the answer as a single fraction. So I think I'm going to rewrite then that last fraction as 4x over 1, and I'm going to find a common denominator for all three. Okay, so I'm going to get on my denominator then, I'm going to have the 3 and the x plus 1 and the 1, which doesn't really do anything. So it's just going to be 3 lots of x plus 1. Okay, so how many times does x plus 1 go into 3x plus 1? It goes in 3 times. So I'm going to have to multiply the 2 by 3. So 3 lots of 2 plus 3 goes into 3 lots of x plus 1 times. So I'm going to do 7 minus 5x times x plus 1. Didn't come out very well. Let's just write that again. X plus 1. And then I've got 1 goes into 3x plus 1 3x plus 1 times, so I'm going to get plus 4x lots of so I'm going to get 3 times 4x lots of x plus 1. Okay, I'll tidy that up in a second. Okay, right, so what does that give me? 3 times 2 is 6. I've got some brackets to multiply out, so I'm going to use FOIL on these brackets. So 7 times x is 7x. 7 times 1 is 7. Minus 5x times x is minus 5x squared. And minus 5x times 1 is minus 5x. And then I've got 3 times 4x, which is 12x. And then 12x times x, which is 12x squared. And 12x times 1, which is 12x. Okay, so quite a long numerator still. I'm sure we can tidy that up a little bit. Not really going to do anything with the denominator just yet. I'm hoping I'm going to cancel some bits out. Right, so what have I got now then? Let's start collecting like terms. Terms in x squared. Got a minus 5x squared and a plus 12x squared. So combining those together, that's going to give me 7x squared on the top. Then what about terms in x? I've got a 7x, I've got a minus 5x, and I've got a 12x. So 12 and 7 make 19, take away 5 is 14x, isn't it? So it's going to be 7x squared plus 14x. And then I've got numbers, 6 and 7, which adds up to 13. Okay, so I get 7 lots of 7x squared plus 14x plus 13 all over 3 lots of x plus 1. Okay. Now, does that factorize? I'm just going to double check to see if it factorizes, because it might be that it cancels down with that x plus 1 if it does. So, can I factorize the numerator? Well, if I could, then I would have a 7x and an x, I guess, here. Factor pairs are 13, a few and far between. It's 1 and 13. I don't think that's going to work out, is it? Because if I put the 13 there, I'm going to have a huge number of x's in the middle, and if I put the 13 there, I'm not going to have 14x in the middle. So no, it doesn't factorize, unfortunately. So it doesn't mean it doesn't look like I'm going to cancel it out with my 3 lots of x plus 1 after all. So I'm going to leave it there then. Okay, that's about as far as I'm going to get. Question 51, simplify fully y squared minus 3y times y squared plus 10y plus 21 over y squared minus 9. Now I'm hoping there's going to be some factors going on here that I can cancel. Okay, now the first part has got a common y, so let's just factorize y out of that first bracket there. So that's going to be y lots of y minus 3. And then I'm multiplying that by, the numerator looks like it should factorize into 2 brackets. If it does, I'm going to get a y and a y. Factor pairs are 21, 1 and 21, 3 and 7. That's about it. Now, which pair gives me 10 in the middle? It's going to be plus 3 plus 7, and it's that pair, isn't it? Okay, so that's going to give me 10 in the middle. So, and then on the bottom of that that fraction, I've got y squared minus 9, and that's difference of 2 squares, isn't it? So that factorizes into y plus 3, y minus 3. Happy days, I can see things I can now cancel. So I can now cancel the y plus 3 and the y plus 3 there. And I can also cancel the y minus 3 and the y minus 3 there. So that doesn't leave me very much then, does it? What's left? I've got the y at the front, and I've got the y plus 7 at the back. Okay, now that is it. That's all that's left. I guess I could write y squared plus 7y, but I'm not sure that's any more simple than y lots of y plus 7. So I'm just going to leave it there. Next section is on special graphs. So we need to know about all the various graphs that come up at GCSE. I guess you've got the sine, cosine, tangent graph. You've got the reciprocal curve, which is one I've got here, plus the exponential curve, and we'll see what else crops up, but that sounds like most of them. Plus, of course, you've got quadratics, cubics, and the rest. And circles, actually. So, anyway, question 52, circle a possible equation for the graph below. Well, this is a reciprocal curve. I know straight away, because I know my graph types, it's going to be that one there. Okay, y equals x cubed, that's a cubic, looks like that. Y equals cos x is that wibbly wobbly one, and sin x is a wibbly wobbly one that starts in a different place. So yeah, it's none of those, it's going to be y equals 1 over x. B, this is the graph of y equals 2 to the power of x, it's an exponential curve. Write down the coordinates of A. A is the point of intersection, it's always the same point, it's always 0, 1. I already know what that is, 0, 1, always passes through 0, 1. Doesn't matter what the value of the number is, the base, 3 to the x, 4 to the x, 5 to the x, half to the x, always goes through 0, 1. It's because any number to the power of 0 is 1, isn't it? Okay, so it's always 0, 1. Question 53, a graph has equation y equals x cubed plus a, where a is an integer. The graph passes through the point 3, 29. Draw the graph of for the values of x from -3 to 3. Okay, right, I think I'm going to use the table function on the calculator to find the points in a minute. But before I do, I really need to find that value of a, and I can find the value of a by subbing in the value of x and y that I've got from the coordinates. So because I know the graph passes through that point 3, 29, I can say that the y value 29 is equal to the x value 3 cubed plus a. Okay, so 3 cubed is 27, so 29 equals 27 plus a, so a must be equal to 2, and therefore the equation is y is equal to x cubed plus 2. Okay, right, so next up I'm going to plot, well, I'm going to find the values. I'm not going to work them out myself, I'm just going to use the calculator to do it. So -3, -2, -1, 0, 1, 2, 3. And I'm going to go into the table function of my calculator and work it out like that. Okay, now I'm going to be using the newest version of the Casio calculator. If you don't have the new one, you might have to go back into one of my other videos to find out how to do it on that one. But anyway, it's not that hard. Okay, so I'm going to go into, so I'm going to press the home key and select the table function for this one, which is there. And once I'm in the table function, right, so I'm going to press the tools button and then I'm going to put in the table range. Now my table starts at -3 and goes up to 3, and I'm going up in steps of 1. Okay, and you can see then now my numbers in the x column are populated. Now I need my f of x value, don't I? So I'm gonna press the tools button again, and I'm going to define f of x g of x. Just want f of x for this one, and I'm going to type in the function x cubed plus 2. Okay, so just typing that in, and then you can see my table is now populated. So I've got at -3 I've got the value of -25, at -2 I've got -6, at -1 I've got 1, at 0 I've got 2, and at 1 I've got 3, and at 2 I've got 10, and at 3 I've got 29. Okay, so they're all my values that I need to plot. So now I just need to plonk them down on the graph then, isn't I? So I've got 1 at -3, 25 down here, and then -2, 6, -2, -6, it's going to be here, -1, 1, there, 0, 2, and then 3, so then 1 goes to 3, 1 goes with 3, and then 2 goes with 10, and then 3 goes with 29, like that. Okay, so we've got this typical cubic curve, which you can then join up with a nice smooth curve. It's quite hard to do on this thing. Easy to do it on with a bit of with a pencil, nice sharp pencil. Okay, just make sure you've got one continuous curve. Okay, preferably a little bit finer tip than my effort there. Okay, but generally, yeah, as long as you skewer each of the points as you go through, you don't feather, then you should get the marks for drawing your curve properly. Okay. Question 54a, sketch the graph of y equals x cubed. So the shape of the graph is very similar to what I just drew. This one goes through the origin though, doesn't it? It kind of goes up like that then. Okay, that's the kind of classic x cubed curve. So x squared plus 3. So x squared would be a parabola through the origin like that. Okay, but we're going 3 units up, so we're going to get a parabola passing that's kind of been shifted 3 units upwards. Something looks like that. I'm just going to mark 3 there where it goes through the y-axis. Okay. Part C says sketch the graph of y equals 1 over x. 1 over x is a reciprocal curve, so it looks like that. Important points is you should not touch the axes. They're asymptotes, so they should kind of approach but never touch. Okay, should be vaguely symmetrical. Mine looks a bit pulled at the bottom there, but I think I'll get away with that. Question 55, draw the graph of y equals 0.8 to the power of x for values of x from 0 to 6. So I'm going to use the table function again in my calculator. So go into the home key and select in the table function. Next thing I'm going to be doing is I'm going to be typing in the range. So tap on the tools and go to table range. This time we're going from 0 to 6 up in steps of 1. Once I've got the range typed in, you'll see that my x column is now populated with 0 to 6. I need to find the f of x column now, so I'm going to press the tools button again. I'm going to go down to define f of x, g of x, select f of x and type in the function 0.8 to the power of x. Okay, so this is what we call an exponential function. Let it work out the values for me. Okay, and then I'm going to write these in. I'm just going to round them off to 2 decimal places if they go larger than that, because you know we're not going to get anything more accurate than that on my graph. So when x is 0, f of x is 1. When x is 1, I get 0.8. When x is 2, I get 0.64. When x is 3, I get 0.512. I think I'm going to just round it off to 0.51, just stick with 2 decimal places. Next one is going to be 0.41 to do 2dp, and then 0.33, and then finally 0.26. Okay, then plotting those points carefully on the graph. So 0 goes with 1, 1 goes with 0.8, 2 goes with 0.64. Now I've got 5 little divisions between 0.6 and 0.7, so each one of those is going to be 0.02. So 0.64 is going to be 2 little squares above 0.6. Okay, 0.51 is like half a square above 0.5. Then I've got 0.41, which is going to be half a square above 0.4. And then 0.33, which is going to be 1.5 squares above 0.3. And 0.26, that's going to be 3 squares above 0.2, like that. Okay, so you can see I've got like a gentle curve running down like that then, haven't I? So just joining that with a smooth curve. Like that. That looks all right. Question 56, here is the sketch of y equals sine x from minus 360 to 360. So I've got 2 periods of the sine curve basically here, haven't I? So write down the coordinates at P. So, you know, remember that sine goes from 0 to 1 when between the values of 0 and 90. So like halfway up at that high point up there, it's going to be at 90. So by the time it comes back down again, that's going to be 180, isn't it? Okay, so what's the coordinates of P? It's going to be 180, 0, because it's going through the axes. And Q, over there, look. So going the other way, that's going to be minus 90, minus 180, and then that's going to be minus 270 there then, isn't it? So minus 180, minus 90, like that. Yeah, it's going to be minus 270. And the height is always going to be 1 for sine. That's about as high as it's going to get. So the maximum point on the sine curve is 1. So it's going to be minus 271. Next up, we've got functions. So we're going to have to know how about function notation, how it works, how we can sub values into functions. We're also going to need to know how to find inverse functions and composite functions. So all that fun. Let's crack on. F of x equals x squared minus x cubed. Circle the value of f of minus 3. Well, f of minus 3 basically means you are subbing in minus 3 where you see x. So it's going to be minus 3 squared minus 3 cubed. Minus 3 squared is 9. Minus negative 3 cubed is negative 27. So I've got 9 minus negative 27, which is the same as 9 plus 27, which is 36. So my answer is that one there. 53, f of x equals x over 3 plus 4, and g of x equals 6x squared plus 3 for all values of x. Work out f of g of x. So f of g of x is take function g of x and stick it inside f of x. So I'm going to take 6x squared plus 3, and I'm going to imagine it where the x is here in the f of x function. Okay, so f of g of x is going to be x, which we're going to replace with 6x squared plus 3 over 3 plus 4. Okay, so that bit stays the same. Look, it's there and there. It's just we're replacing the x here with the 6x squared plus 3. Okay, then what? Well, I can factorize out a 3 out of that top bracket. Look, so that's 3 lots of 2x squared plus 1 over 3, and then they're going to cancel, plus 4. And so I'm going to be left with 2x squared plus 1 plus 4, which is plus 5. Okay? For all values of x, f of x equals x squared plus 1 and g of x equals x minus 5. Show that f of g of x equals x squared minus 10x plus 26. Right, so again, I'm going to take g of x, x minus 5, and I'm going to imagine it where the x is in f of x. So if f of x is equal to x squared plus 1, then f of g of x is going to be taking x minus 2 and replacing that x with it. So I'm going to get x minus 5, sorry, not 2, x minus 5. So that's g of x, and it's going to be inside the rest of the f of x function, which is there, look. Okay? So yeah, that's what we're going to do. We just need to work that out now. So what is x minus 5 all squared? I've got a perfect square there. If you remember your identity, a plus b all squared equals a squared plus 2ab plus b squared. Very handy little identity. That means when you've got these double brackets or these brackets that you're squaring and you need to expand them, you can do it quite quickly. So here I know that's going to be x squared minus 1 times minus 5 times 2 is going to be minus 10x plus 25 plus 1. Okay, if you don't like using the identity, you can just write your brackets out twice and use FOIL. Okay, but I kind of remember the identity, it just kind of speeds things up for me. Right, so then tidying that up, I've got x squared minus 10x plus 26, then is my final answer. Oh look, that matches what I was meant to get, so that's good. Solve f of g of x equals g of f of x. Well, we know f of g of x, we don't know g of f of x yet. So what's g of f of x? G of f of x is doing the opposite. It's taking the f of x and writing it in g of x where the x is. So rather than writing x minus 5, I'm going to replace the x with f of x, which is x squared plus 1, and then the rest will be the same as g of x, so x squared plus 1 minus 5. So that's equal to x squared minus 4 then, just collecting the terms together. Okay, and so solve it. So I need to then stick those two things together then. So f of g of x equals g of f of x. So f of g of x is that expression there, isn't it? And g of f of x, that one there, look, is that. So what I'm going to get is I'm going to get x squared minus 10x plus 25 f of g of x, and I'm going to make that equal to x squared minus 4, which is g of f of x. And then I'm just going to kind of simplify it and collect like terms and things. Now I've got an x squared and an x squared on either side, so I'm just going to cancel those straight away. I'm going to bring the 10x to the other side, make it positive, and the minus 4 to the other side, and that's going to give me 29 is equal to 10x, and then divide them through by 10. I'm going to get x is equal to 2.9. That's going to be my answer, 2.9. F of x equals 5 minus x and g of x equals 3x plus 7. Simplify f of 2x plus g of x minus 1. Okay, so what we're doing here is replacing x in f of x with 2x, and we're replacing x in g of x with x minus 1. Okay, so in other words, we're going to replace the x here with 2x, and we're going to replace the x here with x minus 1. Okay, so f of 2x is going to be 5 minus 2x, and I'm going to add on g of x minus 1, which is going to be 3 lots of x minus 1 plus 7. Okay, so then tidying that up, that's going to be 5 minus 2x plus 3x minus 3 plus 7. So what have I got there then? I've got minus 2x and 3x, that is x, and I've got 5 minus 3 plus 7, which is 9, I believe. So is it x plus 9? I think so. X plus 9. Part B says solve g of minus 1 of x equals 2x. Now g to the minus 1 of x is the inverse function. Okay, so if I've got g of x equals 3x plus 7, I want to work out the inverse function of that. Now to do that, I start off by letting y be equal to the function itself. So y is equal to 3x plus 7, and I rearrange to make x a subject. So I'm going to get y minus 7 is equal to 3x. So then x is going to be y minus 7 over 3. Okay, so then once I've rearranged it like that, then I can say that g to the minus 1 of x is going to be, well, it's going to be this expression here, but the y replaced back with an x again. So it's going to be x minus 7 over 3. And the inverse function is, if you put a number into the function, get another number, the inverse function will take you back from that other number back to where you started from. Okay, so that's my inverse function of g to the minus 1 of x, and I've been told that's equal to 2x, so I'm going to put it equal to 2x. So x minus 7 over 3 is equal to 2x. Solve for x. So multiplying through by 3, I'm going to get x minus 7 is equal to 6x. Collecting the x's on the right, taking x away from both sides, I'm going to get 5x equals minus 7. Dividing through by 5, I'm going to get x equals minus 7 fifths. And that is my solution then. X is minus 7 fifths.
Mr. T, he's